In this module, we want to discuss things like the difference between instance and local variables. We also want to take a look at our branching statements, the if and the switch constructs. And we'd like to look at the iteration constructs of the while and the for loops. So let's go ahead and take a look. In this module, we're going to cover a wide range of topics. For instance, we'll learn the difference between local variables and instance variables. We'll also discuss many of the Java software operators and their precedents. In addition, we'll talk about promotion and casting and how it's used to convert from one data type to another. And finally, we'll cover things such as the branching statements, if and switch, and the looping statements, for, while, and do while. There are two main types of variables in Java. There are local variables, and then there's instance variables. There's another one called a class variable that we allocate with the static attribute, but we'll just be discussing these first two to get an idea of the scope of a variable. Now, as you can see, we have two edit windows here. We have a class called scope example with one instance variable, an integer I, and two methods, first method and second method. And we have a class called test scoping with our main method. What we want to do is illustrate the difference between a local variable and an instance variable and its scope, that is, its visibility. And also how these variables get allocated in stack memory and heap memory. The first thing we do in the main method is create a scope example object and assign its reference to the scope variable. Now the scope example object will be allocated in heap memory, while the scope variable will be allocated in stack memory. Now the scope variable is a local variable to the main method. When the main method exits, the scope variable will be automatically destroyed. The scope example object, on the other hand, gets destroyed by the garbage collector when there are no longer any reference variables referring to it. Now on the next line of code in the main method, we call first method of the scope example object. And in the first method, we declare two local variables, integer I and integer j. Now those variables also get allocated in stack memory and are local to this method. That is, they can only be used inside this method. Now notice that the local I variable has the same name as the instance I variable. So whenever this occurs, the local I variable takes precedence over the instance variable. So if we want to refer to the instance variable, we must use the this reference that you see in line 6 of the scope example class. So we have this.I. So that refers to the instance variable I, whereas the plain I on the right-hand side of the assignment operator refers to the local variable. So we're adding I plus j, so that's 4 plus 5, and assigning that value of 9 to the instance variable I because of the this.I reference. Then we're calling a second method and passing a 7 in as the argument. Now again, here we have an argument called I. This will be allocated in stack memory as well. And we have a local variable called j, which will also be allocated in stack memory. Now this I and this j are local to this method and can only be used within this method. And the I and j from the first method are completely invisible to this second method. So local variables may only be used within the method that they are declared. Now the instance variable I is visible here because it has object scope, not local scope. So once again, though, to refer to it, we must use the this reference. So this.I. And the unadorned I variable refers to the local I, the one that is the argument that we passed in. Now in this case, we will be adding 8 plus 7 to get 15 and assigning it to the instance variable. Now when this method exits, the local I and j variables for this method will be deleted from the stack. And then when the first method exits, the I and j local variables for that method will be removed from the stack. And then when we go over and we exit from the main method, like I mentioned before, the scope variable will be removed from the stack. And now, since no variable is referring to the scope example object, that object may also be removed from memory by the garbage collector. Now, we've already discussed the 8 Java primitive data types. We learned what their minimum values were, what their maximum values were, and how many bytes in memory they each took up. Now, what we want to discuss is their default value. That is, if you create a variable of one of these types, and you do not specify a value for it to be initialized to when it is created, what will it be assigned? Now, for the byte, short, int, and long, you will get a 0. For the float and double, you would get a 0.0. And for the Boolean, you will get a false. And for the char data type, you would get the null or the 0 character, which isn't a character at all. And there is one last type of variable that will get an initial default value if you do not specify one. And those are the object reference variables. They will get an initial value of null assigned to them. Null is a special keyword. It's N-U-L-L, all lowercase. And it basically means that the reference variable points or refers to nothing. Now, this default initialization value only applies to instance attributes and class attributes, those variables declared with the static modifier. Local variables do not get a default value. You must specify a value before you use them. So let's take a look at this. Go ahead and click the Initialization Before Use tab. So this is an example of where you must specify a value for a local variable before you use the local variable, because local variables do not get a default value assigned to them like the class or instance variables do. So here we can see what's happening. We have an integer x, which we are assigning a random number. We then have an integer y, and we are not giving it a default value, and then an integer z without a default value as well. We then have an if statement where we're checking to see if x is greater than 50, and if it is, we are initializing it to y equal 9. If it isn't, we skip the if block, and we then go to the next line, and we have z equals y plus x. Now here is our problem. You see, we are now initializing z, which is good, and we already have x initialized, which is good. But y will only be initialized at this point if the x variable had a value greater than 50 and we entered the if block. If not, then y would be uninitialized at this point. And so the compiler is giving us an error message. See, it figures out all of the possible paths for a variable and figures out whether or not, when it reached this path, if it would have been initialized in all paths. And in this case, it will not have been initialized if the x value was not greater than 50. So we get a compiler error. So to reiterate, instance variables and class variables get a default value specified based on the table we just took a look at. Local variables do not get a default value, and you must initialize them to some value before you attempt to use them. As this table shows, Java has a wide range of operators that we have access to. Now, we're not going to go over all of these because it would take too long, but we will point out a few of them. Now, this table also shows us the operator precedence. So if an operator is at a row higher than another operator in a different row, then that operator takes precedence over the other operator. If the operators are in the same row, then they are evaluated for the most part left to right. There are a couple exceptions to this rule. So let's just take a look at a few of these from this table. For instance, the plus plus and the minus minus operator. These are shortcut operators that increment and decrement a variable by 1. So instead of saying x equals x plus 1, you could just say x plus plus. Then we have our standard multiplication, division, addition, and subtraction operators, which are the asterisk, the slash, the plus, and the minus. Then we have the bitwise left and right shift operators, which we'll take a look at in a second. And then the relational comparison operators. We have less than, greater than, less than or equal to, and greater than or equal to. Then we have the equality operator and the not equal to operator. Now in Java, the equal sign is an assignment operator. It assigns a value to a variable. And the equal sign is the equality comparison operator. And then the exclamation point equal sign is the not equal to. Then we have our logical operators of AND, XOR, OR, and the short circuit logical operators of the logical AND and the logical OR, which is the double ampersand and the double vertical bars, which we'll take a quick look at in a second. And then we have the various assignment operators. We have the equal sign, which is pretty standard, but then we have these shortcut assignment and arithmetic operator combinations. So for instance, the plus equal sign is a shortcut for adding a value to a variable. So instead of saying x equals x plus 3 to add 3 to a number, we could just say x plus equals 3. So let's click the logical tab and take a look at the logical operators. Now we have the not, the and, the or, the XOR, and then we have the short circuit and OR, which are the ones we use most often. Now what these do is evaluate one side of the operation, and if it's possible, they will not evaluate the other side of the operation. So for instance, if you look in our code window, you can see we are getting a myDate object, and then we are checking to see if that reference variable is not equal to null, and if the day attribute of that object is greater than 31. So if the left-hand side of that AND operation is false, then it will not evaluate the right-hand side. That's because a false and anything else will always be a false. So it can short circuit that. Same thing with the short circuit OR operation. If the left-hand side is true, then there's no reason to evaluate the right-hand side, because true or anything is always true. Now let's take a quick look at the bitwise logical operators. So go ahead and click these. Now what these do is they perform the logical operation on the bit level. So for instance, the not operator usually takes a true and converts it to a false, and a false to a true. When working at the bitwise level, it goes bit by bit and converts zeros to ones and ones to zeros. Same thing for like the OR. We go bit by bit between the two numbers, and if you have two zeros, you get a 0, and if you have a 0 and a 1, you get a 1, and if you have a 1 and a 0, you get a 1, and if you have two 1s, you get a 1. So the 1 is the true, and the 0 is the false. Let's click the bitwise shift tab. Now, bitwise shifting is an advanced topic, so we're not going to say much about it. What it allows you to do is shift bits in a number to the right or to the left. Now click the string concatenation tab. Now, string concatenation is done using the plus operator. So if you have two numbers, the plus operator does addition. But if you have a string on either side of a plus sign, you then do string concatenation. So if you take a string plus a string, you get a new string. And if you take a string in any other object or any other primitive, you will get string concatenation as well. So for instance, if I take a string plus the number 3, the number 3 is automatically converted to a string and then string concatenation done. If I take a string plus, let's say, a customer object, the customer object will get converted to a string by calling its toString function, and then those two strings will get concatenated together. Now another thing to note is that when you do string concatenation, you get a new string created. Strings in Java are never changed. They're what's called immutable. That means once you create a string object, its value can never be changed. There are many times in which we have a variable of one type, and we'd like to take the value from it and put it into a variable of another type. Now, sometimes this can be done automatically. This is called promotion. And other times, we must do it manually, and this is called casting. So we're basically going from one data type to another, such as an integer to a long. Now, as long as you go from a smaller data type to a larger data type, the conversion can be done automatically. This is called promotion. And what I mean by a smaller data type is I mean a data type that has a smaller range of values from the min to the max. So that range of values can fit within the range of values of the other data type that you're trying to assign the value to. For instance, we see in our diagram a byte can be promoted automatically into a short because the byte range of values is from negative 128 to positive 127, and that fits within the range of values for the short, which is negative 32,000 and something to positive 32,000 and something. So the byte fits perfectly within the short. Now the short can go into an int based on the same reasoning, an int into a long into a float into a double. Also, a byte can go into an int, or a byte can go into a long, because again, same reasoning. The value range of the byte fits nicely within the value range of the integers or the longs or the floats, etc. There's no way to lose any data during this conversion. So here we see in our little edit window, we see an example of automatic promotion. We have an integer variable called x, which has a value of 5. And then we are able to assign the value in the x variable to the y variable because we are going from an int to a long. So no possible loss of data. Let's click the Promotion Examples tab and take a look at some more examples. Now here we have a long called BigVal, which we're setting equal to 6. Now remember, 6 is an int literal. So here we're doing automatic promotion, going from an int into a long. That's perfectly acceptable. On the next line, we are declaring an int called smallVal, which we're setting to equal 99L. So that's a long literal. Now this is illegal because you're trying to go from a long to an int. Now that's down the diagram that we just showed you, and that's illegal. So we'd get a compiler error that would say possible loss of precision. On the next line, we're declaring a z variable of type double, and we're assigning it a literal float value. And remember, a float has a smaller range of values than the double, so it can be automatically promoted into a double. The fourth and final line is illegal because the 12.414 is a double literal, and we're trying to take a double literal and assign it to a float variable. Again, down that diagram that we showed you. So what would we do if we really did want to go from, say, a long to an int, or from a double to a float? Well, then we have to use casting. So go ahead and click the Casting tab. With a cast, you are overriding the compiler's warning to you about the possible loss of precision. So you have to accept the consequences for these actions. So if you want to do it, what you do is in parentheses, you put the data type that you want to cast to. So for instance, in our example, we have a long variable called BigValue that we're setting to equal 99 as a long. We are then trying to take BigValue and assign it to an integer called squashed. So that line number 2 is wrong because we need a cast, and the compiler will give us an error message. On line number 3, we are doing it correctly. We are using a cast, that's the int in parentheses, to tell the compiler to go ahead and do the conversion from long to int. Now if the long value is outside the range of integers, such as either too big or too small, then the result could be anything. You could get a negative number, a positive number. It can do all kinds of weird things. So you have to make sure that when you do a cast, that the value that you're casting from is acceptable to the variable that you're casting to. Then, again, on line 4, we're trying to convert a 99 as a long literal into the integer, and that's illegal. We need a cast. So on line 5, we are doing a cast, which is okay, but again, this is kind of weird because all you'd have to do is take the L off the 99 to make it an int. And then on the final line, you see that we're setting squashed equal to 99 as a literal int. Now let's take a look at the branching statements in Java. There's 2 of them, the if statement and the switch statement. We're first going to look at the if statement. The simplest format of the if statement is the if keyword followed by a Boolean expression in parentheses. If the Boolean expression evaluates to true, then we execute the following statement or statement block. If the Boolean expression is false, we do not. So in our edit window, we see an example. If x is less than 10, we will execute the next statement, system.out.println, are you finished yet? Click the If Else tab. Here we have expanded onto the if statement by adding an else portion. In this case, if the Boolean expression evaluates to true, we will execute the statement or statement block following the if statement. If it evaluates to false, then we will execute the statement or statement block following the else keyword. We can see this in our edit window. If x is less than 10, then we will print out, are you finished yet? But if x is not less than 10, we will print out, keep working. Now click the If Else If tab. Here again we have expanded upon the if statement. This allows us now for multiple conditions. So in this case, if the Boolean expression for the if statement evaluates to true, then we will execute the statement or block following it. If it evaluates to false, then we will go down to the next if statement following the else and see if that is true. If it is, we execute that statement or block. And we will continue down the various if statements looking for a Boolean expression that evaluates to true. If none do, we will then execute the else block at the end, if there is one. Here in our example, we are getting an integer called count. If the count is less than 0, then we are going to print out a message, error, count value is negative. If count is not negative, then we will go to the next else if portion and check that Boolean expression to see if the count is greater than the max count. If it is, then we will print out error, count value is too big. Now if this also returns false, then we will go down to the else block, which acts kind of like a catch-all. Here, then, we will print out there will be, whatever the count is, people for lunch today. So the if statement allows us to do simple decision making in our Java code. The second branching statement is the switch statement. Now this statement may only be used with the byte, short, char, and int data types. And this statement is used when you are taking one variable and comparing it to multiple values. So we begin the switch statement with the switch keyword, and then we put our variable inside parentheses. This is the variable that we will be comparing to the different values. And then for each value that we want to compare it to, we issue a case statement and then the value. And then after the case statement, we have the statement or statements that we want executed if that variable equals that value. And then we'll have an optional break statement, which we'll explain in a second. And then lastly, you can have an optional default section that will be executed if none of the values specified in the case statements match the variable in the switch expression. So let's take a look at an example to understand this. We have switch car model. So car model is our variable that holds the value that we want to compare to the different cases. The first case is deluxe. Deluxe is some constant defined someplace that we are going to compare to the car model value. If the car model equals the deluxe value, then we will execute the following methods: add air conditioning, add radio, add wheels, and add engine. Then we issue the break statement. This causes us to exit the switch statement. If we did not have that break statement in there, we would fall through to the next case statement and begin execution of those lines of code, even though that case did not match the variable value. And we'll see why you may want that in just a second. So now the next case statement is standard. So if car model equals standard, then we would instead execute add radio, add wheels, add engine, and then issue the break statement to leave the switch statement. Now, if the car model is not deluxe and it is not equal to standard, then we will execute the default block, which is kind of the catch-all. And in that case, we would call the add wheels method and the add engine method. So why would you ever want it that when you are done executing one case of statements, you fall through and into the next case of statements? So let's look at this example again. Notice that we always, in all the cases, call add wheels and add engine. We do that for the deluxe model, we do that for the standard model, and we do that for the default. We also call the add radio method for both the deluxe and the standard model. So we are repeating a lot of lines of code. Let's see how we could rewrite this to not have to repeat those lines of code. So take a look at the example on the right. Here we're using fall through, which means we've taken out the break statements. So if the car model equals deluxe, we will call the add air conditioning method, and then we will fall through to the standard case, and we will execute the add radio method. And then, because there's no break statement here either, we will fall through to the default section and call add wheels and add engine. So these method calls are equivalent to what we had before for the deluxe case. Same thing with the standard. If the car model value equals standard, we will call add radio, then fall through and do the add wheels and the add engine. So with fall through, we've eliminated a lot of the duplication that we had in the previous example. Now let's take a look at the looping statements in Java. There's 3 of them: the for loop, the while loop, and the do while loop. Let's begin with the for loop. Now the for loop allows you to loop over a statement or block of statements. And it begins with the for keyword, and then in parentheses we provide it with 3 pieces of information separated by a semicolon. The first piece of information is the initialization expression. This allows you to declare and initialize a counter variable. So if you see in our code windows, we have declared an integer I, which we are setting equal to 0. And then after the initialization expression, we have a semicolon. And then next we have the test expression. The test expression is our Boolean expression. If it evaluates to true, we execute the code in the loop. If it evaluates to false, we will leave the for loop. So in our example down below, we have I is less than 10. So that is what we are checking. If the integer I is less than 10, then we will execute the for loop. And if it is not, we will leave the for loop. And then after the test expression, we have a semicolon. And then lastly, we have the alteration expression. This will either increment or decrement or some way alter the counter variable. So in our case, every time through the loop, we are telling it to increment I by 1. So we have 2 versions of our example, and they both accomplish the same thing. The first one doesn't use a code block, so it illustrates that the for loop can execute one statement, and the second one does use a code block. They both are equivalent. However, I prefer the second one because it's clearer where the beginning and the ending of the for loop is. So, once again, just to reiterate, the initialization expression will allow us to declare a variable and initialize it. This is our counter variable. This happens at the beginning of the loop. Then we have the test expression, which is a Boolean expression. If it's true, we execute the loop body. If it's false, we leave the loop. This happens every time through the loop. And lastly, we have the alteration expression. This alters our counter variable. It can increment it, it can decrement it, it can multiply it by 2, it doesn't matter. But every time through the loop, at the end of the loop, this expression gets evaluated and changes our counter. Now let's take a look at the while loop. The while loop has a much simpler syntax than the for loop. We begin with the while keyword, and then in parentheses we have our test expression. If the test expression evaluates to true, we will execute the next statement or statement block, and then loop again. If the test expression evaluates to false, we will leave the loop. So down in our edit window, we have an example of this. We first declare an I variable of type integer and initialize it to 0. Then we begin our while loop. We check to see if I is less than 10. If it is, we will execute the code in the statement block. If it isn't, we will leave the while loop. Once we are done executing the code in the statement block, if I was less than 10, we will then return back up to the while loop and retest it. Every time through the while loop, you can see we are going to increment I by 1. So eventually it will hit 10, and then we will leave the loop. So as you can see in our output, we get the various values that are the square of the numbers from 0 to 9. Now let's take a look at the do while. Here in this example, we will get the same output, but we are just doing it a little differently. Now with the while loop, you are not guaranteed that the statement or statement block will be executed at least once. That's because the test expression could evaluate to false the very first time, and then you would never execute the while body. But with the do while, you are guaranteed that you will execute the statement or statement block at least once, because the test expression is at the end of the loop. So let's take a look at the syntax. We begin with the do keyword, and then we have a statement or statement block, followed by the while keyword, and then our test expression in parentheses, followed by a semicolon. The semicolon is very important. So let's take a look at our example in the code window. We start again by declaring an I variable of type integer and initializing it to 0. Then we have our do keyword and then our statement block. So this will get executed at least once. So it's going to get executed right away. And then we will have our while statement where we do our test. It is here we will decide if I is less than 10, and if it is, we will go back up to the top of the loop and loop again. If it is not, we will leave the loop and continue on with the code after it. So this example also gives us the same output as the for loop and the while loop. Now most of the time you will code the for loop and the while loop and the do while loop the way that we showed you. That is, waiting for the test expression to evaluate the false to leave the loop. But there are times where you may want to get out of a loop right away. And to do that, you will issue a break statement. So in our code template window, we see a do while statement, and then we have in the middle an if statement. If this if statement evaluates to true, we're going to issue a break statement, which will force us to leave the do while loop immediately. It doesn't matter what the test expression evaluates to. It doesn't even check it. We just leave immediately. Now click the Continue tab. The Continue tab is kind of the opposite of the break statement. What it does is it skips any of the code that's left in the loop body and goes down immediately to the test expression and retests the test expression to see if it's true, and then we'll do another loop. So sometimes in a loop, you find a condition, in which case you don't want to continue executing the current loop iteration, you want to go to the next one. So you issue a continue statement. Now click the Break Labels tab. In this case, we have nested loops. We have a do while within another do while. Now, a traditional break statement will only take you out of the loop statement that it is in, not any other loop statements that it's nested in. So it will always take you out of the innermost loop statement. So if I need to get out of nested loops, I will need to put a label on the outer loop and then issue a break statement specifying that label. So in this case, we've put a label called outer on the outermost do while loop. And the label is just a valid identifier with a colon preceding the loop statement. And then when I issue the break statement, I will say break outer. And this will cause me to leave both of the loop statements, the inner do while and the outer do while. Click the Continue Labels tab. The same thing happens with the continue statement. If you have nested loops and you issue a continue statement from within a nested loop, you will only go to the innermost test expression. But if you want to go to an outer test expression to see if you should continue the outer loop, you must label the outer loop and then issue a continue statement specifying that label. So again, here we have nested do while statements, and we have labeled the outer do while with a label called test. And then when we issue our continue statement, we are saying continue test. And that will cause us to go to the test expression of the outer loop. In this module, we covered a wide range of topics. For instance, we discussed the difference between instance and local variables. We also discussed many of the Java software operators and their precedents. In addition, we covered promotion and casting and how it's used to convert from one data type to another. And we ended with the branching statements, if and switch, and the looping constructs for, while, and do while.